Hi students, good morning. Today we'll study the branching. Okay, the programs will be stored in the consecutive in the memory locations, and also execution of the program will be executed in the sequentially. Okay, sometimes the logic will be repeated. Logic will be repeated. Then the length of the code of the length of the program will be more long. In such a situation, the repeated code will be written in the loop, or sometimes in the ISR, that's nothing the subroutine program also. In such a program should be called wherever it is necessary in our program. That is to be done with the help of the branch instructions. That is done with what the branch instructions means. What the if the programs are executing in the sequentially, and also programs are written in the sequentially, the program the some logics are will be repeatedly used. Okay, those logics are repeatedly. If you're writing the program in the straight line, the length of the code will be more, becomes what larger. In such a situation, the repeated code, whichever the code will be using the logic, the particular code will be written in the particular in the small program that we call as the subroutine program. Okay, wherever it is necessary, we can call that program with the help of the branch instruction, or else you can also use the loop also. Sometimes it is necessary to have the repeatedly we need to add the particular number in the repeatedly, no, then the until that number reach, then the we have to keep on track. That one will be done with the help of what the looping of the instruction. With this one only we will study here branching. What is the branching? What is the branching? Every time it is not possible to store the program in the what the consecutive memory locations. In the consecutive memory locations is one by it is not possible to store. And also after the execution of the decision making instruction, in which one of the two programs sequence, in which the after the execution of the particular decision making instruction, I will have the two programs option. Okay, in such a case we cannot use the straight line sequencing. Or else, okay, if your statement is there, then we cannot go with the what the consecutive sequentially. It's in such a straight line sequencing is not possible to execute the program. In here we have the we use the what the branch instruction. We will be used what the branch instruction. You will use what the branch instruction to transfer the program control from the one straight line to the what the sequence to the another straight line sequencing. It means here the if you are writing the program in the main program, if you are using the some program, in this program you will be using the some code. Okay, the some code which will be repeatedly used in the length of the code will be increasing. In such a situation we will be writing the small program that we call as the subroutine program. In such a program we will have the some addresses. Those addresses will be called to where in the with the help of the branch instructions. After execution of this instruction, the control will comes back to where comes back to whom the main program itself. Then the straight line execution. These are means for the two straight lines. One is the main program straight line sequence. Another one is the subroutine program straight line sequence. In such a situation, we will have the control to come to where in the here the small program. Even the distant programs are there. Yes or no, yes or no. In such a situation, the branching is the sequence of code will be cannot be executed in straight line. It will come the control will come to either of one. Okay, it will come to, if it's true, that will come execute the this line of code. If it's wrong or not false, then the this line of code will be executed. In such a situation, straight line sequencing is not possible. Okay, in such a conditions we cannot use the straight line execution of the straight line execution of the program. So such a situation will use what the branch instruction. Branch instruction will do what? No, that will transfer the control of the main program to what the separate small program, and also it come after execution of that small program comes back to where main program itself. This is one way. Another way is to use the branch instruction for the looping purpose also. The looping, if you are adding the n numbers in the program, then the definitely we cannot add the sequential one by one. It is better to use what the for loop. Okay, for loop. If you are using the for loop, here the I equals to 0, I plus I is greater than the If it is greater than the 0, I plus plus. Okay, then the I is to be incremented for every single. Okay, up to the reach what the it is to reach for the particular range. Okay, particular condition. Then only it will stop the for loop also. In such situation, we will use the branch instruction. Branch instruction. Okay, one thing you remember, branch instructions are used to looping, in the looping, and also even you will be using the subroutine programs in order to execution, or else you also use the control transfer from the one true or false also, or if else statements also. In such a situation, branch instructions are used. Okay, I hope it is clear for you. Okay, just to copy whatever written on the board, I'll continue with the another example. Okay, let us consider the execution of the, let us consider the adding of the n numbers, in the sequentially. It means here the we are writing the program with the help of what the assembly language, that is the using the instructions to address instructions, and the move instructions move the number one to what the in the R naught. This is having the address location, memory location address is what the I itself. After the I is incremented with what the 4. Next number is added. Number 2 is added here. Number 2 is added to what? To the R naught. R naught is having what the value? Number 1. Number 1 plus number 2. The result becomes where in the R naught itself. In the R naught itself. In the R naught itself. Then the number 3 is added to result of R naught. Then the stored where in the R naught itself. It means here the this is the source register, this is the source, this is the destination. This is the source, this is the destination. R naught number 1 is moved to copy to where in the register R naught. Number 2 is added to R naught. R naught was having the what the value? Number 1. Number 1 plus number 2 is added together. Then the result is stored where in the R naught itself. In the R naught itself. Okay, the result is added. The result is added to number 3. And which means here we are adding the number sequential one by one. 1, 2, 3 like this. Okay, some numbers are adding one by one, up to what the n numbers of. Okay, you have to what the add n numbers of together, up to n numbers we are adding here. Okay, we are doing what the n numbers here. We are adding the n numbers. Okay, n numbers, that's nothing but the number 1 R naught. Okay, number 1 number n up to the with the R naught itself. Okay, the sum will be stored where in the in the registers R naught itself, in the registers R naught itself. Okay, that's to be done with the help of what the sum is done with what the copying. Okay, the sum is where in the register R naught itself, so that this is to be done with the help of the copying purpose will be using the move instruction, that's to be done with what the R naught. That's the move to where in the R naught, that is to be moved where in the sum. Okay, sum. For addition of these numbers, we have this is what the instruction storing, first instruction, second instruction, third instruction. For every instruction, the address of the memory location is incremented with the 4, incremented with 4, I plus 4, I plus 8, like this, because of the we are using the 32 bit of word. Okay, then we have the I plus of 4n. Okay, I plus of 4n minus of 4. In this at this stage we'll be having the what the type of the number here, the we are doing the what the addition of the n number on or not. Okay, sum is stored where in the particular memory location, and also number 1, number 2, number 3 up to we will be having the this is what the storage of the storing of the memory, and also even we will be storing the numbers. Okay, operands also in this. The memory is used for the storage of the writing of the program, and even the storing of the what the operands also, numbers also in this also, result is also like this. This is up to what the program, this is what the up to program for addition of the n numbers. If we ask in the examination for the addition of the n numbers in the sequential, we are doing what the sequence additions. Okay, The addition is repeating, the addition is repeating. Okay, the n numbers, how many times will be writing here like this, how many n numbers, it's becomes what the large program, it becomes a large program, and even it's executing sequentially, when we are storing the sequentially. Okay, it's not the good one. Okay, if we were to go with what the looping, if the n number is storing where in the, is moving to where in the r1, the clear r0, the we are using the r0 is for the storage purpose. Determine the address of the next number, add the next, and add the next number to what the in the r0, r0 plus r1. Okay, r0 plus of r1, r1 is having the n numbers, r0 is having the result of that one. We don't have any results now. r0 plus 1 n is what the 0 plus 1 is 1, next is 1, 1 plus 2 is what 3, like this. You'll be repeating up to what the reach what the, this is what the sometimes. For example, you consider the this is what the 20. Okay, this n numbers, up to n numbers, okay, up to 20 numbers, it is adding together, adding incrementing. And also this is decremented always. This is what the decrementing 9 18. Okay, that earlier was what the 19. Okay, 20 of it was earlier 19, 18, and 17. Like this, it is the decrementing the decrement the r1, and the branch it will be reach up to what the 0 numbers. It is the repeating. The loop is repeating. This loop comes where in the this loop. So okay, this will be repeating up to what the, after reach what the 0, up to what the reach the 0. The sum, the result is stored where in the register r0. The result is stored where to back to where in the sum itself. Like this, we are doing what we are the operations branching. We are doing what we are the branching because of the loop. Okay, this will be repeating up to what the reach to what the branch equals to what the 0. Earlier branch was what the n has to reach what the 0 numbers. This will be repeating, where the code will be repeated, that is to return where in the some piece of code. This is what we call as the subroutine program, or else we can also write the loop in the loop. We are doing what the looping the until to reach what the 0. I hope you are, it is clear for you. And also operands also written in this memory locations also. This is the what the program. This is the straight line programming, straight line program for the adding the n numbers. This figure. Okay, using the loop, we are adding the n numbers here. Means what the branch is, if you use the branch instructions, okay, it's better to have the small, will have the small piece of code here. And also memory is also consuming the memory is also less, so that we will get the good uh, okay, good line of code here. Okay, better code. Okay, it's best to have the use the branch. Okay, with the help of what the looping. This one we call it the branching. This one is called as branching. How I hope it is clear for you all. Okay, you just to go through this one. This is, they will ask for the 10 marks in the examinations. Okay, all the best students. Okay, you follow up the my YouTube channel for the students purpose only. We are doing here yeah, for the study purpose. Okay, now we are not earning any money here, just for your revision. If you are not able to attend the class, yeah, at least you can refer this videos also, these videos also. Thank you for watching the video.